Hi everyone, welcome back. Today we are solving minimum ASCII delete sum for two strings. So in this problem, we'll be given two strings S1 and S2, and we want to return the lowest ASCII sum of deleted characters to make two strings equal. So every time we delete a character, then we will have to add the ASCII value of that character to the ASCII sum. So if we look at this example, if we delete S and T, then these two strings will be equal, and the value of S is 115, for T is 116. So if we add that up, it will be 231. So that's why we return 231. And in this example, we will delete one E and another E from here, and also DE here. So then the two strings will now both be let. And if we add up the values, it will be 403 because D has a value of 100 and the three E's both all have a value of 101. So if you add that up, it will be 403. And that will be what we return. So now that we have seen some examples, let's get to how we can solve this problem. So to solve this problem, we can use dynamic programming. So first we will make a grid of size length of S1 plus 1 by the length of S2 plus 1. So grid of 0, 0 will be 0, and the rest of the first column, which is this, will represent S1's total ASCII values up to that index. So this would be ASCII value of this character. This will be the ASCII value of this character plus this character, and this will be the ASCII value of these three characters added up. And the same will be for the first row. It will represent S2's ASCII values. Now, as we go through this grid, we will compare the characters, and if these characters are equal, then that means you don't need to delete them, you can keep them. So we would just set it to its top left value. So let's say if these two are equal, then we'll just set this to 0 as well, because we don't need to delete these two. Now, if they are not equal, then we will either get the ASCII value of S1 at this index plus what's from the previous row. So what that will mean is we will delete this character, so that's why we add this, and then we will get whatever we have from above. Now this option would be we add whatever is here, meaning we will delete this, and then we will take whatever we have on the left side, so the previous column, and we will set the grid to the smaller between A and B. Now if A and B are equal, that means we will delete from both S1 and S2, meaning we'll delete both characters, and then we can set it the grid to either this or this, since they will be equal. And finally, when we get to here, we will return the bottom right value of this grid, which will be right here. So let's go over this example real quick. Right here, we will have the ASCII values of all the characters that we will need for this example. So first, E and S are not equal. So for this case, we will have to delete both, because if we add this to this or add this to this, they'll be equal. So we will set it to 216. Now A and S are not equal, and in this case, we will also delete both, since if the problem ends here, we will have to delete all of them. And right here, T and S are not equal, so again, we will have to delete both. So up to this point, they will all have to be deleted. Now we move down here. E and E are equal, so we can just add its top left. A and E are not equal, and in this case, it will be better to delete A. So we will add 97 to 115, and that will be 212. Now T and E are not equal, and again, it will be better to delete T. So we will add 116 to 212. Now E and A are not equal, so it will be better to delete A instead of E. So we will add 97 to 115, and that will be 212. A and A are equal, so we will just get its top left, which is 115. Now T and A are not equal, and it will be better to delete T. So we would add 116 to 115, and that will be 231. And finally, we will return 231 as our result. So the time complexity would be O of n times m, where n is the number of characters in string 1, m is the number of characters in string 2, and the space complexity would be O of n times m as well if we lay out the whole grid. But there's actually a way where we can do it in O of m time complexity or O of n time complexity, depending on which you set as the row. But in the coding part, I would do it in O of m time complexity, but I just did it in O of n times m space for the example walkthrough because I feel like that would be easier to understand if I lay out the whole grid. But in the coding part, I will show how you can do it in O of m space as well as O of n times m space. So now let's get to the coding part. So this is how the code can look like if we want to solve in O of nm space, or like how we did in the example walkthrough. First, we will set up the 2D grid, then we will fill out the 2 strings, and then we will fill out each position in the grid, and then we can return dp of rc, which is the bottom right value in the grid. Now to solve it in O of m, we only need to do it by one dimension, so dp of 0 times length of s2 plus 1. And now we will go ahead and set up s2 in the dp grid, so it would be dp of I is equal to dp of I minus 1 plus the ASCII character, which would be s2 of I minus 1. And now we will loop through the grid. So for R in range 1 to length of S1 plus 1. Now we will set previous to dp of 0. And now we need to set up the rows or the ASCII character of S1 or string 1. So dp of 0 plus equal order of S1 of R minus 1. Now we can loop through the columns. So it will be for C in range 1 to length of S2 plus 1. And if they are equal, then we will set the value to prev. So that would be its top left. Else, if they are not equal, then again, we will have 2 options. So it will be the minimum of the ASCII character of string 1 of R minus 1 plus dp of C. Now, dp of C right here would still be the previous row because it has not been edited yet. Now, the other option would be order of S2 of C minus 1. So the ASCII character of S2 of C minus 1 plus dp of C minus 1. Now, dp of C minus 1 will be the current row because it has been edited. And we will set previous to dp of C for the future iteration, and we will set dp of C to the value. And finally, we can return the last value in dp, so dp of -1, see if it works. Okay, perfect. Hope this was helpful. Thank you all for watching. If you have any other questions or comments, feel free to leave them in the comment section, and I hope to see you all again soon.